In this video, we'll look at the very modern problem of e-waste, or electronic waste. The production and disposal of electronic materials has increased exponentially over the last several decades, and as we'll discuss, these materials have unique properties that make them potentially dangerous to dispose of, but which also make these materials valuable. The global e-waste problem has only been discussed over the last decade or so, and as you'll see, we have a long way to go to address this issue effectively in many countries, including, and perhaps especially, in the United States. In this video, our three objectives are to explain what e-waste is and where it's found, describe why e-waste is dangerous but also valuable, and lastly, we'll look at the current fate of e-waste and compare and contrast the approaches in the European Union versus the United States. All the figures in this video, except for a couple of photos, come from the report that is listed here, which was published in 2020 and in my opinion represents the best global analysis of the e-waste problem that is currently available. You can download this report for free from the ewastemonitor.info website shown here if you want to learn more. For our first question, what is e-waste? The answer is probably fairly obvious. I think everyone is well aware of the number of electronic devices that are now in your life. If you look back over the last decade and add up the number of smartphones you've owned, that number is probably 2 or 3 or 4, hopefully not too much more than that. Do the same for computers, televisions, and all the other electronics in your life, and you can start to imagine the scope of the problem. What happens to all these devices and appliances when you're done with them? Do you throw them in the trash? Do you take them to a recycling facility? Can you even find a recycling facility to take these devices to? If you live in the United States, the answer may very well be no. So let's take a closer look at the different categories of e-waste in the next slide. There are a number of different categories of materials that are common in e-waste. And as you'll see, these include both small electronics and large appliances. The first category is temperature exchange equipment, and this includes refrigerators, freezers, air conditioners, and heat pumps, which are another way of heating and cooling buildings. The second category, screens and monitors, needs no other explanation, as we're all probably familiar with those types of devices. The third category, lamps, is one you may not have thought about as much, but modern light bulbs, including fluorescent and LED bulbs, contain a number of elements that can be dangerous when they're disposed of in a standard landfill. And so these types of materials also qualify as e-waste. You can read through the other categories yourself, but it includes everything from large appliances, printers, calculators, electric shavers, laptop computers. Just about all the essentials of modern life fall into this general e-waste category in one way or another, if they're powered and if they're complicated in any kind of way. So what is so particularly dangerous about e-waste? If you were to pull apart a laptop computer, you would take off the case, which might be made of plastic or aluminum depending on who you bought the computer from, and under that case you'd see a large battery. Most everyone these days knows about lithium batteries. These are present in phones, laptops, and even in electric cars. As it sounds like, these batteries contain lithium, but they also typically contain a number of other elements depending on the application. Those other elements can include manganese, cobalt, nickel, and phosphate, which is a form of phosphorus. The rest of the computer will contain a number of different elements that make up the components of the motherboard, the processors, and the other parts of the computer. Every element that is shown with a crosshatch pattern in this version of the periodic table is used in some kind of electronic device. These elements are used because of their specific chemical properties that support the functions that are needed in these devices. But there are two problems with many of these elements. The first is that many of them are dangerous, even in low concentrations. Elements on the first list under the periodic table, which include cadmium, mercury, lead, chromium, and arsenic, are commonly used in electronics and are also toxic in even very low quantities. These elements have a range of effects on human physiology and in some cases function as neurotoxins. So if you were to imagine taking apart your computer and pulling apart the pieces within, you would likely be exposed to some of these elements and potentially in large enough quantities to pose an important health risk. The second key point about these elements is that many of them are rare, meaning they're present in very low concentrations in the Earth's crust and are therefore quite valuable. They actually have a name called rare earth metals, and they include a range of elements, many of which you've likely never heard of. But they have unique properties, and elements like lanthanum, the La on the list, or neodymium, the Nd on the list, play important roles in certain electronic applications. The other interesting thing about these metals is that they're not found in very many places, and at present China is the dominant global producer of these elements. There are deposits in the US, Australia, and other nations, but as you can imagine, there are even national security issues that revolve around the production of these elements because of their scarcity. Keep that in mind when we talk about recycling and reusing the metals that are found in electronics, or more specifically, why we're not recycling and reusing more of these metals. The graph on this slide shows e-waste generation across a range of different regions. As you can see, the largest amount of the waste is generated in Asia. That's shown in the dark blue bar in the middle of the graph. But if you divide that value by the number of people living in Asia, you get the turquoise-colored bar, which is much lower than other regions. So even from this very broad breakdown of global production patterns, we can see that electronic use tends to increase with higher levels of disposable income, higher urbanization, and more industrialized economies. E-waste would increase for the same reasons, but more specifically, the production of waste increases with higher consumption rates, short product life cycles, which means products that are not designed to last very long. And it increases when products are built without repair options and have to be thrown out rather than repaired when they fail. We produce a lot of e-waste. What then happens to it all? This is where the story gets a little depressing. So on average, about 7.3 kilograms of e-waste are produced per person per year, and about 17.4% of that is properly collected and recycled. The other 82.6% goes somewhere, but isn't tracked. Probably a lot of this waste ends up in landfills, or it might get shipped to another country where it might become part of an informal recycling process that we'll talk about in a minute. If you look at the recycling rates across region, the statistics that really stands out is how much better Europe is than anywhere else, and how much higher the recycling rates are compared to the Americas, and specifically to the United States, which is also very low. This is a result of much stronger policies focused on the creation of recyclable electronics and the development of systems that support recycling of these types of waste. The thing that is really shocking about the lack of recycling is how much money is actually left on the table. There are about $57 billion worth of raw materials disposed of in e-waste each year. $57 billion worth of materials that would not need to be mined or processed for use in electronic creation. Recycling could provide 64% of the materials that are needed for new electronic production, and yet globally, we only recycle about 17% of these materials. What that means is that we end up doing a lot more mining of rare earth metals for no good reason, and we end up disposing of those materials that contain a lot of dangerous elements that could easily find a second life in a new product. Why does that happen? Well, frankly, it's simply because there's not the political will to create the legislation that is needed to correct this problem. There is another problem that emerges from this unnecessary production of e-waste, and it is related to the value of these materials. As we've talked about, the elements that are present in e-waste are valuable, but they're also not effectively recycled. Some new e-waste is also transported from country to country, and then it ends up being recycled and sorted in informal settings by people who have no access to protective equipment, who work under unsafe conditions, and who work for very low wages. As we've talked about, the elements that are present in many types of e-waste can be very dangerous, and so it's probably not surprising that exposure to these elements in uncontrolled conditions creates potential health problems for the people picking trash, and for their families, including children who can be exposed to these metals and other elements in utero. So how do you solve the e-waste problem? The answer is to basically do things differently, to reduce generation, promote recycling, and put legislation in place to prevent dumping and illegal processing. Countries can also support the development of industries that are focused on electronic refurbishment or e-waste recycling. In the United States, for example, all these things are doable if the problem was prioritized and addressed in congressional legislation. Wrapping up this video then, we know that e-waste includes a range of consumer electronic products from small electronics to large appliances. We know that e-waste is dangerous because of the nature of the metals and the elements that are present in many electronic devices, and many of these elements and metals are rare, and so they're valuable. Despite this, most global e-waste is disposed of in standard sanitary landfills or exported to other countries where it may be handled under unsafe conditions. And if we want to give credit to one part of the world that's doing a much better job than the rest of the world, we can give a hand to the European Union for trying to tackle the problem of e-waste.